Oke, selamat siang semua, mahasiswa. Hari ini saya akan menjelaskan terkait dengan data preparation and cleansing. Jadi begini, sebelum kita melakukan yang namanya dalam mekanisme IT itu kadang-kadang kita membutuhkan namanya data analisis ya. Nah, dalam data analisis itu kita perlu memahami pertama nanti yang disebut dengan database. Nanti ada beberapa video yang saya tayangin, nanti dari video tersebut kalian bisa mengambil pelajaran, kalian bisa memahami apa itu database dan penyebutan apa itu kolom, apa itu entity, nanti sampai di ujungnya membuat ERD diagram. Nah, tujuan pembelajaran ini adalah memahami bagaimana data diatur dalam sistem informasi akuntansi, memahami bagaimana data disimpan dalam database relasional atau relation database, kemudian menjelaskan dan diterapkannya teknik ekstraksi, transformasi, dan pemuatan atau loading. Kalau suka dipendekkan dengan ETL, Extraction, Transformation, and Loading. Nah, nanti saya akan share nih ada beberapa video yang bisa kalian lihat untuk memahami apa itu database sebelum kita berbicara panjang lebar. Nah, di sini kalian nanti bisa melihat ini ada video, ada berkaitan dengan database. Ini dari Vertabelo, iya kan? Ini nanti ada berkaitan dengan apa? Di kolom ini video ini berkaitan, habis itu dilanjutkan dengan entity relationship diagram atau ERD atau entity relationship diagram 2. Nah, mari kita lihat videonya berkaitan dengan database. Apa itu database? Sebelum kalian melangkah lebih jauh berkaitan dengan mata kuliah ini.
Learn how to design databases with Vertabelo. Part 1. Tables. What is a database? A database is a place where we store the data. Structured data. What does it mean? Database structure is strictly connected to a physical entity we want to model. Let's say we want to store information about people, but first we must create a structure. To store the data, we need a table which defines what data we want to collect, the type of data, what data is mandatory, what data must be unique, etc. Tables define the structure of the data. The data is stored in rows. So in the table person, we will keep such data as social security number, first name, last name, date of birth, address, phone number, etc. Think of a table as a description of a data element in a single row. A table represents the kind of information stored inside its rows. Inside a database, we can have more than one table. For example, we might want to store information about people's cars. A car's description would be vehicle identification number, brand, model, production year, and so on. Now we've got two tables, person and car. In these two tables, we can store data about many people and many cars. In the next video, you will learn about columns and their data types. Vertabelo. Design databases online. Database design tutorial. Learn how to design databases with Vertabelo. Part 2. Table columns and data types. In the previous video, we talked about what a database is and what a table is. We defined two tables, person and car. It is a structure, the definition of what kind of data will be stored in a database. The structure of a table consists of columns. Every column definition must have information about its data type. Columns may have different types: numeric, strings, date and time, and many others. Data types are dependent on a database management system. Oracle, IBM DB2, Microsoft SQL Server, PostgreSQL, MySQL, and others. Let's take a quick look at the most commonly used data types. Integer, a number without a fractional component. It's also one of the most commonly used data types. With integer, you can store a number of products, number of people, or numerical identifiers. Float, an inexact floating point number. You could use it to hold your weight. It doesn't need to be very precise. Decimal, an exact specified precision decimal number, perfect for storing money. Character, a fixed length string, is good for codes that have a constant length. Character varying, a variable length string holding no more than n characters. That's the most common type for storing short textual data. Date, a date without time of day. It's used when the exact time doesn't matter or is unknown, for example, date of birth. Timestamp, both date and time. Use it whenever you have to keep an exact time of occurrence of an event. Boolean, logical value, true or false. It could be information such as whether someone watched this video to the end or not. Binary large object. They may be images or long text, for example. So now let's define data types for cars columns. Vehicle identification number is exactly 17 characters long. Brand is a variable length string, 50 characters should be enough. It's the same case with a model. Production year is an integer. First registration date is a date. Photo is a binary large object. Information about whether a car is registered or not is a Boolean value. Price is a 2-digit precision decimal number which must be exact. Mileage may be an inexact floating point number. And time of last refueling is date and time, that is, timestamp. Now, try to do the same with a person table. After you do that, watch our next video explaining how we can model a relationship between a person and a car. Vertabello. Design databases online. Database design tutorial. Learn how to design databases with Vertabello. Part 3. References. In the previous videos, we defined two tables, person and car. They describe what data we will collect about people and cars. Both a person and a car have some data that identify them. In the case of a person, it is social security number. And for a car, it is a vehicle identification number. These are their identifiers. In this database model, there is no relationship between a person and a car. But in reality, people own cars. Or, in other words, cars are owned by people. In the database world, this kind of relationship is represented by a reference. A reference defines that there is a relationship between the tables it links. It also shows how they are related to each other. The relationship may be of one of the following types: one-to-one, one-to-many, or many-to-many. What does it mean? A one-to-one relationship means that one row from table A is related to at most one row from table B, and vice versa. A single row from table B is related to at most one row from table A. For example, one country has one president. One president represents one country. Another example of a one-to-one relationship. One husband has one wife. One wife has one husband. In a one-to-many relationship, one row from table A may be related to many rows from table B, but every row from table B may be related to at most one row from table A. This is the case with football players and their clubs. One club has many players, but one player belongs to at most one club at a time. It's also true for a mother and her children. One mother has many children, but one child has exactly one biological mother. Finally, in a many-to-many relationship, the maximum multiplicity in each direction is many. An example of many-to-many relationship may be students and classes. One student signs up for many classes. One class has many students sign up for it. Let's try to find out the type of relationship between our tables person and car. We will start with a one-to-one reference. Now, one person may be the owner of only one car. One car is owned by one person, but it's not true. One person may have many cars. So, let's now link them with a one-to-many relationship. This means that one person may be an owner of many cars. This is okay, but here, one car may still have only one owner. That is also not true. Let's reverse the relationship. Now, a car may have many owners, but one person may have only one car. It's not our solution. So, here comes the many-to-many relationship. It says that one person may have many cars, and one car may have many owners. That's it. Now, let's go through all kinds of references and see how references affect our tables, and how they look in the data. If we create a one-to-one reference, we must add a new column to one table. A column with an identifier referencing another table. It is called a foreign key. So we have to add the owner's social security number to the table describing a car. It's very important that this column is of the same data type as the column identifying a person. It will hold the same data. And here is how it looks in the data. For a one-to-one reference, we add a column to the car table with the owner's social security number. Now we see that a car with VIN 123 is owned by a person with SSN 001. A car with identification number 345 is owned by a person identified by 002, and so on. In the case of a one-to-many reference where one person may have many cars, nothing changes. With such a structure, we can supply that same person's SSN for multiple cars. In fact, if we want to make a one-to-one reference, we need to assure that values in the foreign key column are unique. We do it with additional constraints, which will be explained in further videos. If we want to make a one-to-many reference where one car may have multiple owners, we need to add a foreign key column to the person table. Now we see that many people may relate to the same car. For example, a car with VIN 123 is referenced by a person with SSN 001 and a person with SSN 002. But the many-to-many reference is a little bit more complicated. Note that with such a structure we cannot store information both about multiple cars owners and multiple people's cars. In such case, we must add a third table called a junction table. At the very least, it must contain foreign key columns. Rows in this table contain data which link both the person and car tables. For example, a person with SSN 001 owns two cars, the VIN 123 and 345. A person with SSN 002 owns only one car, 345. A car with VIN 123 is owned by one person, 001. A car with VIN 345 is owned by two people, 001 and 002. As you can see, we now have a many-to-many relationship. Can you now identify and model a relationship between a book and an author? Vertabello. Design databases online.
Hi, my name's Taylor and I'm from Lucidchart. Today you'll be learning all about entity relationship diagrams, or ERDs. We're going to start off by discussing a high-level overview, and then together we'll dive in and build an example together, complete with entities, attributes, relationships, and cardinality. By the end of this video, you'll be able to build an entire entity relationship diagram from scratch. Have you ever wondered why you get an error message telling you that your ideal Twitter handle is already taken? Or how Amazon can keep track of so many different orders and customers and products? The answers to these questions lies within the creation of a database, which, in other words, is a collection of information that is organized so data can be easily stored, managed, updated, and retrieved. Now, there's a lot of moving information in a database, and understanding how the many elements of a database interact with each other can be difficult to grasp. Engineers need a visual way to understand how all these separate elements are related to each other and how they're working together. To show this, they build entity relationship diagrams. So let's talk about how you're going to make these ER diagrams. You can draw them out with pen and paper, but it's going to be way easier for you to use a diagramming tool. Today I'm going to use an easy-to-use tool called Lucidchart, and you can too, for free actually. By clicking on the top right corner here, you can access Lucidchart's website, enter your email address, and have a free account in just a few seconds. That way you can follow along with me and continue building your own ER diagrams as well. Before we can create an actual ERD, we need to better understand the individual components of the entity relationship diagram. And this is going to start with entities, which are an object, such as a person, place, or thing, to be tracked in the database. For example, in the case of buying something on Amazon, let's say a Snuggie, an entity could be a customer, an order, and lastly, we can't forget our Snuggies, the product. Now, each one of these entities is going to have what we call attributes, which are various properties or traits. In this case, under the customer entity, we have a customer ID, first name, last name, street, city, zip, and phone. It's important to remember that the entities in your database will be the rows, and that the attributes in your database will be depicted as the columns. Now, we have the different entities and the different attributes on the screen here. But now let's talk about the relationships that exist between these different entities. The relationships describe how these entities will interact with each other, if at all. And you do that by drawing a line in between them. So when I draw a line in between these particular elements, I'm showing that there is some sort of interaction or connection in some way. Now that we have our relationships in place, you'll see some funky notation attached to these lines. This, in fact, is called the cardinality, which further defines the relationship in a numerical context, particularly within minimums and maximums. So for example, here on this right side, you can see some different types of cardinality we have in ER diagrams. We have one, many, one and only one, zero or one or many, zero or many. Now don't be afraid if this isn't making sense quite yet. We're going to walk through some examples that will help you understand this perfectly. So let's talk about the relationship and the cardinality that exists between a customer and the order. Now the best way to do this is to think about it logically. We have to think about what is the minimum number of orders that a customer could have, and what's the maximum number of orders that a customer could have. So let's start with minimums. What is the minimum number of orders that a customer could have? Well, a customer could exist, but he or she could have 0 orders. So to show that over here, we'll have that 0 sign. Now we have to think about the maximum. What are the maximum number of orders that a customer could have? Well, as you probably already know, a customer can have infinite orders. In the case of Snuggies, you can never just have one Snuggie. So to show that, we'll use this 0 or many crow's foot notation. Now let's talk about the minimum and maximum relationship between orders and customers. So we ask ourselves the same questions. What is the minimum amount of customers that an order may have? And what's the maximum number of customers that an order may have? Now a specific order can only have one and only one customer. Well, you can imagine the confusion that could come if the same specific order had lots of customers. So in this case, there can be only one and only one number of customers to an order. And we can show that using this sign here. So now let's talk about the relationship or cardinality between orders and products. So we'll ask ourselves the same question. A certain order can have how many products? Well, for an order to exist, it has to have one product. But a lot of different products can be comprised of that order. So to show that on our diagram, we'll change this notation. Now we ask ourselves that question in reverse. A product can be a part of how many orders? Well, a product could be a part of no orders, but it also could be a product of many orders. So we're going to use this 0 or many notation on our diagram. So now you've built your entire ER diagram, and we've built something small here, but now you have the foundation and framework that you need to build complex, complete entity relationship diagrams. Although this can seem a little bit overwhelming at first, just be sure to walk yourself through that logic, and you'll be able to build entire complex ERDs. You'll also see on this diagram that there are some unfamiliar objects such as PK and FK, which refer to primary keys and foreign keys, something that we're going to be covering in a video coming soon, so stay tuned. Additionally, if you need to actually have this diagram to be database ready, you can use the import and export features of Lucidchart to have all of that done automatically for you. Using the export feature, you'll have that code automatically generated for you and exported to the database management system you're using. Thanks for watching this tutorial on ER diagrams. Subscribe to our channel below to get access to more helpful videos and tutorials. Leave a comment as well if you have any thoughts or questions on ERD. And don't forget, sign up for a free Lucidchart account by clicking on the link in the top right corner. Thanks. Hi, my name's Taylor, and I'm going to walk you through some advanced ERD concepts. Today we're going to be going over primary keys, foreign keys, bridge tables, and then really understanding how ER diagrams help you see exactly what's going on in your database. So let's start where we left off, with our very simple diagram from the previous tutorial. So we've got entities for customer, order, and product, and the correct cardinality between. You'll notice that next to each attribute is the word key. This column is here so we can distinguish certain attributes as either primary keys or foreign keys. Let's start with primary keys. This is probably easiest to understand if we step out of the diagram and into the table it represents. Remember, each entity in your diagram represents a table within your database. So let's look at the customer entity as a table with rows and columns. We've got all these different instances of the customer here, and if you're Amazon or something, you've got millions of customers all within this table. Wouldn't it be nice if you could use a single trigger to quickly and accurately distinguish who's who in this massive list? That's where a primary key comes in. A primary key is an attribute or field that uniquely identifies every record in a certain table. And since a single attribute can accomplish all that, it makes sense that you'll just need one primary key per entity. So for this customer table, the primary key is going to be a value that makes it so that this customer is unlike any other customer in our table. For one of these attributes to qualify, there are a few rules. First, a primary key has to be unique so that it identifies only one record in your table. Second, it needs to be never changing. It'd be pretty difficult to keep an accurate record of your customers if you're using an attribute that might not stay consistent. And finally, a primary key needs to be never null. That just means there wouldn't be an occasion where the value could be left blank. So let's look at a specific customer, like John here, and determine what data might uniquely identify him. Well, you can't rely on names because two totally different customers could very easily share the same first and last name. There's a John Smith here and a John Smith here, but they're two completely different customers, so it's not a unique record in this table. You can't even rely on an address because you could have two separate customers living at the same place. Or a customer could move and then their address changes. So an address isn't unique and breaks the rule of never changing. Same thing for a phone number. So that leaves us with customer ID. By design, any sort of ID is typically programmed to increment for each addition to the table. This customer signs up and is assigned customer ID 30016. Then this customer signs up and is assigned 30017, and so on. You can see how customer ID passes all our rules. John's customer ID will completely identify him as a particular instance in our database, and that value won't ever be repeated in this table. So we're going to make that our primary key. Here's something interesting to think about while we're on this topic. Have you ever tried to create a username for an account and then later wanted to change your username to something else because it was hard to remember or stupid or something, but then you can't because the site won't let you? Well, that's probably because your username is being used as a primary key in that site's database, and primary keys can never change. That's how the site is linking you, the customer, to your account. They don't let you change that primary key because their system relies on it for accurate records. Or how about when you're setting up a new account and you try to create a username but get an error message saying that it's already taken? Again, this could be happening because the username is being used as the primary key, and a primary key can't be repeated. In our example though, we're just using a randomly assigned customer ID number as our primary key. We know this will always be unique and never repeated. So let's jump back to our diagram and note this by putting PK next to our customer ID. And I'll go ahead and quickly clear out all this other text to make things clearer. Now let's apply those same rules to find primary key for our other entities. Let's quickly jump into the order table that this order entity represents and zero in on a specific instance. Here, it looks like our customer, John, placed an order to go to this address and it shipped at this time. Looking at the data, what could be our primary key? We already know names and addresses are no good, and ship date isn't going to work either. Two orders could be shipped at the exact same time, so that's not a unique attribute. It's pretty clear that order number is the primary key. So we put PK next to that attribute in our diagram. And finally, we can look at the table that this product entity represents. Let's say our customer, John, purchased this product here, a beautiful Snuggie. You know by now that product ID is going to be the primary key in this table. So we note that in our diagram too. Each of these primary keys is unique, never changing, and never null. So you probably noticed that I'm using a diagramming software to modify these ERDs, but just know that the same concepts apply if you're drawing them out on pen and paper. But if you want to make things easier on yourself, you can sign up for the diagramming software that I'm using, for free actually. It's called Lucidchart. All you have to do is pause the video, click on the card in the top right corner, and sign up for an account. All it takes is an email address and you can follow along with me. So now that we have our primary keys nailed down, let's talk about foreign keys. A foreign key is the same as a primary key, but just located in a foreign place. Maybe you have a primary key in one entity, but it'd be really helpful to pull that data into another entity. That's where you get a foreign key. And we want to make note of these foreign keys so we can better understand how our entities relate to one another. Let's see how this plays out in our diagram. We've already established customer ID as the primary key for the customer entity, but that same attribute is also over here in the order entity. Why? Because for each order we record, we want to know exactly which customer placed that order. The order entity is simply referencing the customer ID from the customer entity. That makes it a foreign key here, so we'll mark it as such. And we can further show this relationship in our diagram by adjusting this relationship to line up with the primary and foreign keys. Just move these crow's feet to line up with the PK and FK attributes. It reinforces the fact that this foreign key in the order entity is referencing the primary key of the customer entity. Let's review how this foreign key works by looking at it in the order table. So here are all our orders. If we look at a specific order, it has a customer ID of 30016. This is a foreign key because it references the primary key in the customer table. Now we know exactly which customer we're dealing with when we look at this specific order. So John made this order here, but look farther down. The same customer ID is repeated because John placed another order. Unlike a primary key, foreign keys don't have to be unique. They can be repeated in a table. If John's an avid shopper, his customer ID is going to be repeated a lot. Another difference between primary and foreign keys is that there can be multiple foreign keys in one entity. Let's say for each order, we also want to know what product is being sold. We'd add product ID to our table. And this is what it would look like in our diagram. We just add another field, type in product ID, and since product ID is a primary key over here, that makes it a foreign key in this entity. Now we have two foreign keys in our order table. There's also something called a composite primary key. Composite primary keys are used when two or more attributes are necessary to uniquely identify every record in a table. So let's say we created a shipment entity, and it's got these attributes here. And then let's take a look at what the corresponding table might look like in order to explain this better. Let's say John ordered a regular Snuggie and then a zebra pattern Snuggie. It's all one order, but they're getting sent in two different shipments. When we look at these two rows and each of these attributes, we wouldn't be able to rely on any single one to give us a unique record. The product number is duplicated when someone else buys that same zebra pattern Snuggie. So it's not a unique record in this table. An order could be parsed into a couple different shipments, like John's was. So order number is also not unique. Charge card time would be duplicated if someone else pays for their shipment at the exact same time. And same for packing time and ship date. All not unique. So it doesn't look like any of these attributes will give us the primary key we're looking for. But what if we took two of these attributes and combined them to create a new unique value, like product ID and order number? Take those two values for any instance, combine them together, and you've got a value that won't be repeated. That's a composite primary key. Now the primary key for this shipment is different than the primary key for this shipment. You could technically call this a compound key because we're using two foreign keys, but usually people just say composite key as an umbrella term. Anyway, jumping back over to our diagram, you note a composite primary key with multiple PK marks. That doesn't mean there are two primary keys. It means that both of these attributes are needed to create a composite primary key. A couple rules here when making these. 1. Use the fewest number of attributes as possible. 2. Don't use attributes that are apt to change because that can make things messy. And you might ask yourself, why not just create a shipping ID attribute so we don't have to deal with this scenario? Well, you certainly could, and that's totally valid. It's actually quite a debate among some people if you should even bother with composite primary keys. But it all depends on the database you're creating and if there are certain scenarios where a composite primary key makes sense. Another thing we can talk about here is something called a bridge table. When you're making your ER diagrams, it's important to ask yourself, is there anything else I should be recording into the database? Sometimes you'll have two entities connected to one another, but there's more going on between them than you're accounting for. That's when you need to use a bridge table. To illustrate this point, I'm going to strip down our diagram to just customer and product. Now, couldn't we just create a direct relationship between these two entities? A customer can purchase 0 or many products, and a certain product can be purchased by 0 or many customers. Sure, conceptually this works. But the way this is set up, you're not going to know when a customer purchased that product. You're not going to know if they bought all of them at once or if they returned to buy more at separate times. You're going to be in the dark on many details regarding the interaction between these two entities. And this issue often occurs when you've got a many-to-many relationship. That's where a bridge table comes in. A bridge table allows for an intermediary one-to-many relationship and gets you the information you're lacking. In this example, a bridge table would be the order entity. Let's put that back into the diagram. You can see how it breaks up the many-to-many relationship, and now each time a customer purchases a product, we're going to have a record of that interaction in our order table. So as you build or modify your ER diagram, make sure you're asking yourself if you're getting all necessary information and use bridge tables to capture that data. If you want to start getting a bit more specific with your ER diagram, you can do so by adding data types for each attribute. This can be really helpful, especially if you'll be doing some programming out of this diagram. So we use an entity shape with 3 columns, and we'll specify the type of data we want on the far right side. For customer ID, we'll return an integer. That's going to give us a number like 501422. And all these attributes here will be varchar, meaning you can use various characters and then set a character limit in parentheses, like this. So for phone number, for example, it's going to have to be 10 digits to fit the standard phone format. There are several different data types and things we won't get into, but just know that you can include these in your ER diagram if you want to get more technical. Now, we've added a lot of detail to this ERD, but what are we going to actually do with it? Building ERDs is a great way to conceptualize and visualize before you've actually built your database. But once you've built the whole ER diagram, you're going to need to translate it into a database management system, or DBMS. Typically, you'd have to just reference this diagram and then manually enter code to create the database. That's a lot of work. But here, Lucidchart allows you to export the diagram, and it will automatically generate the code you need for your database. You can see the table commands here with the entity it's referencing. Here are the attributes for this entity with the data parameters that we set. And it also notes our primary and foreign keys. Then you just specify which database management system you're using, copy the code, and paste it in. Your database is ready to go. It's a total time saver, and if you're a student with an assignment to make a diagram in a database, this is like cheating. It's so easy. Conversely, let's say you've already got a database created, but you want to visualize it. Anyone who's worked in a database management system knows that it's not exactly easy to see what's going on. But an ERD of that database gives you a visual layout. Well, you can just import the database here, and Lucidchart populates all your tables. Drag one out, and it automatically creates the entity with the appropriate attributes, primary keys, and foreign keys. And if you drag out another entity, the correct relationship will automatically connect between them. This is another huge time saver. You can quickly visualize your database, make changes in diagram form, and then pass those changes back into your database via code. Thanks for watching this tutorial.
Nah, 3 video ini sudah menjelaskan ya bagaimana definisi dari database, kemudian contoh-contoh database, tipe-tipe data, gitu ya kan. Kemudian sampai kalian bisa menjelaskan bagaimana hubungan relationship datanya, gitu, dari mulai masing-masing itu berupa flat file, kemudian dijadikan database relation database. Nah, misalkan seperti ini tadi kan, kalau misalkan customer data, sales data, product payment itu adalah disebut dengan flat file, atau kolom-kolom data berdiri sendiri, atau data-data berdiri sendiri, itu namanya flat file. Tapi kalau sudah dihubungkan dengan kaitan satu sama lain, seperti yang dijelaskan tadi di video, itu namanya relational database. Nah, kalau dalam sistem itu, sistem informasi akuntansi misalkan, itu semuanya pasti yang bekerja relational database. Nah, kita mesti lihat di sini kan, makanya tadi ada juga pembicaraan berkaitan dengan foreign key, kemudian berkaitan dengan primary key, tadi sudah dijelaskan primary key itu apa, ya kan? Kemudian foreign key, kemudian ada atribut deskriptif, nanti kita lihat atribut kan, kemudian ada tipe datanya apa gitu, itu seperti yang ada di video. Seperti ada juga dalam slide ini, ini contoh ini seperti yang dari video tadi gitu. Bagaimana kaitannya hubungan supplier ID dengan supplier table dengan purchase order table. Nah, juga ada kaitannya dengan video tersebut. Tolong dipelajari dan dipahami, diulang-ulang nonton videonya. Semoga materi hari ini bisa membantu kalian untuk belajar lebih baik. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.